we're doing conic.
Okay.
And first one would be x, y minus 4 equals 0 and y minus x equals 0.
Hold on. xy minus 4 equals 0?
Yeah. And then y minus x equals 0. Yep.
And what's the question? What are we trying to do here?
Solve the following systems of equations.
Okay. Which is a little different than conics. So, how can I solve this system of equations?
Substitution.
Yeah. So what should we do first?
Add x on both sides.
To equation number
2.
Okay, so we get y equal x. Now we can use substitution. So we get substituting that into equation number 1 for y gives us what?
X times x minus 4.
Now how do we solve this?
Add 4 on both sides.
It's one way. Not sure that's the best, and I'll let you know in a second whether or not it is for you or not.
And then take the square root, so it'll be plus or minus 2.
Very good. You're one of the 10% of my students that remember the plus or minus. Now, the reason I said I'm not sure that's the best way to solve it is because 90% of the students forget the plus or minus. So there's another way to solve it. Notice that that is the difference of perfect squares. Now you can't make a mistake. And then, of course, we have to solve for y also. So we plug in, we look at that equation, and therefore y is also equal to plus or minus 2. This is a little unique. What are the actual solutions?
2 and negative 2.
Well, notice that this equation here is not true if x is positive 2 and y is minus 2. So I can't just say x is plus or minus 2 or y is plus or minus 2. I have to say that x could be 2 and y would be 2, or x could be minus 2 and y could be minus 2. So really those are your two solutions. In other words, I can't put the minus 2 with the plus 2. Notice that that doesn't work, nor does equation number 2 work if you do that. So I'm not sure exactly how you want to spell out your solutions here, but maybe this way where you circle. In other words, 2 comma 2 is a solution and minus 2 comma minus 2 is a solution. Which is a little different than saying x is plus or minus 2 and y is plus or minus 2. Because that would indicate that x could be minus 2 and y could be plus 2. And that's not true. All right. What else?
Y squared equals 4x. X minus 2y plus 3 equals 0.
y squared equals 4x. What was the second one?
X minus 2y plus 3 equals 0.
Okay, what should we do here?
Substitution.
Okay. I mean, you got a choice. When you say substitution, we could solve this for x and substitute that for x, or we could solve it for y and substitute that for y.
Let's solve it for x.
Okay. Now, plugging that in back into equation 1 gives us now what?
Divide y on both sides?
No? What are we looking at?
Oh wait, a quadratic.
Exactly. You always want to recognize when you're looking at a quadratic, because quadratics kind of solve different than most algebra problems. Quadratics, you always want to get everything on one side and 0 on the other. Factor that.
Y minus 6. Y minus 2.
So those are my two solutions, but before we settle on them, let's check them. Oh, first of all, what's x going to be?
2y minus 3.
Well, what number is x going to be?
1.
If you substitute 6 for y into this, what do you get?
Oh, 9.
So x equal 9 when y is equal to 6. What is x equal to and y is equal to 2?
1.
Okay. So our solutions would be 9, 6 or 1, 2. In other words, with these problems, we have to give our solutions in terms of x and y. Now, let's make sure that works in both equations. It certainly works in equation 1, and it works in equation 2 because I derived it from equation 2. I guess that's it. There's nothing else to consider. Notice that x can't ever be negative. Since y squared is always positive, x has to be positive based on equation number 1. Now y came out to be positive with both solutions, so yeah, I guess that's all there is to that problem. All right.
X squared plus y squared equals 10. And y equals x plus 2.
Okay. So x squared plus x plus 2 squared equals 10. What's x plus 2 squared equal?
X squared plus 4x plus 4.
Now if we combine everything, looking at a quadratic again, now what's the next step?
Take out the common factor, so x squared plus 2x minus 3.
So x equals,
Oh,
we got to factor it still. Sorry.
x equals 3 and negative 1.
So we factor it into x plus 3 and x minus 1. So x equal negative 3, x equal 1. And now we need a y value for each of those. So we use equation number 2. So when x is equal to negative 3, y is equal to negative 1. And when x is equal to positive 1, y is equal to 3. So again, your solutions come in pairs like that. And let's make sure that both those solutions work. Well, certainly if I square both of these and add them together, I get 10. Same thing for these. So it satisfies equation number 1, and I know it satisfies equation number 2 because that's where I got the y values from. So the only one I really need to check is equation number
1. X plus y plus 1 equals 0. And x squared plus y squared plus 6y minus x equals negative 5.
Equals with negative what?
5.
It's interesting that I think you're the first student I've ever had that said they were working on conics, and I do have conic equations here. In other words, this looks to be the equation of an ellipse, but I don't really need to put it into standard format to solve it. First of all, let me ask you, have you studied parabolas, circles, ellipses, and hyperbolas?
We touched on it today.
Okay. Because this is the equation of an ellipse, and this is the equation of a straight line. So if I were to figure out how to graph that ellipse, it's going to be, say, an ellipse that looks like that. And if I graph the straight line, looks to be like that. So I should expect two solutions. Both of them have an x and y coordinate. So in essence, the graph is what we're doing here. I mean, this is what the solution, based on this graph, I can tell that I need exactly two solutions, and each one has an x and y coordinate. Okay, so we can solve it the same way we've been solving all of them, but it is worth looking at it graphically sometime. So what should I do first?
Set the first equation equal to x.
Okay, or y, either one. Now what?
And plug it in.
Okay, now
Plug it in.
now we have to be particularly careful because we have so many negative signs that, and even if we didn't, I would say that this is the proper next step always. Spell everything out to the last detail, like this. In other words, don't try to skip a step. If you try to skip a step, inevitably you can make a mistake real easy here, as you can see. It would be hard to do this without writing it out first, like that. So now help me solve this. What's this over here?
Y squared minus,
What's A minus B? Well, yeah, A minus B quantity squared equals what?
Y squared 2y.
Hold on. It's worth memorizing these so you don't have to FOIL it every time. And the other half of this is A plus B squared. In other words, you have to do this operation so many times in your math career that it really is worth memorizing what it's equal to. Because you don't want to have to do 4 multiplications in order to do this. It'd be much better if you can draw in your memory. Well, in this case, we have A minus B. This one's a little tricky to do because of both minus signs. So maybe I should FOIL this one out. But I definitely get y squared there. And then I'm going to get minus 2y. Or am I? No, I think I'm going to get plus 2y, aren't I?
Yeah.
In other words, if I do minus y minus 1 times minus y minus 1, I get y squared and then plus 1y plus another y. So there's plus 2y plus 1. So that's what that, oddly enough, that's what that FOILs out to, is nothing but positives. Can't say that I've come across that before either, where you had to binomially expand 2 negative numbers like that. Okay, plus y squared plus 6y. Eliminate these parentheses here.
Negative y minus.
Try again.
Oh wait, y plus 1.
These parentheses over here I can eliminate without doing anything. Now simplify.
2y squared plus 9y plus 2
Let's move the 5 over.
of negative 3 equals 0.
And presumably this factors. If it didn't, we would have to plug it into the quadratic. Either way, we can figure out what a solution is. What goes here and here?
2y?
The signs? Signs have to be opposite because of that negative sign right there.
Minus.
However, plus minus is not the same as minus plus, so we have to allow for both of them. How many factors of 3 are there?
1, 3.
3, 1. I just randomly plug it in there and see if that works. Does that work? Since it doesn't produce the correct middle number, there's no point in moving the 3 down to here and the 1 down to there. Is all that does is produce the same number with the opposite sign. So I'm not even going to try 3 and 1. I'm going to try 1 up here and 3 over there, and I'll bet that works. Doesn't. Well, I've tried all combinations. Can't factor it. So, what is y equal to?
plus or minus.
Go ahead and give me the general. Hold on.
9.
Hold on. What's the quadratic formula?
Plus or minus.
Actually, it's minus b.
Oh, yeah, minus b plus or minus b squared. Oh, b squared minus 4ac over 2.
Okay. Let's talk about memorizing this. There's two parts to the quadratic formula, is the way I think about it. You got the first part, minus b over 2a. Well, what else is that equal to?
Vertex?
Yeah, that's the vertex, the line of symmetry, the x-coordinate of the vertex. So that's helpful. If we know what the vertex is, then we know what the first part of the quadratic is. The second most important part of the quadratic is the part that is under the radical sign. That has its own name. What is that called? Discriminant, yeah. The reason it has its own name is because frequently we want to know whether there's real or non-real solutions here. In other words, I'm not going to go any further if I know I've got imaginary solutions. Well, maybe I would, but maybe I wouldn't. So it's useful before I proceed into plugging everything into the quadratic formula. It would be helpful to know whether my discriminant is going to be positive or negative, because that's going to tell me whether I have real or complex answers. Well, what is the discriminant in this case? Let's analyze it.
It's positive. So
Very positive, yeah. Because this second part of it actually turns positive. So it's actually 81 plus 24. So the discriminant is 105. So that's helpful. I was going to have to do that anyway. I might as well do it first just to see whether I've got real or non-real solutions. So now y is equal to what? Let's plug in everything.
5 over 2.
What's minus b?
Oh, negative 9.
Okay. Plus or minus. And we already know this is 105, so I can write square root of 105 in there. All over
4.
Can that be reduced? I don't think so. 105, I don't believe, has any factors that are perfect square numbers, does it?
I don't think so.
The only factor I can think that it has would be 5 and 21. And 21 is 7 times 3, so we have 5 times 7 times 3, all prime numbers. So there's no way we're going to reduce that. So, what are the two solutions for y?
Negative 9 minus 100, square root 105 over 4.
And?
Equals negative 9 positive square root 105 over 4.
Okay. Now we need an x value for each of these y values. So, go up to where x is defined. X is equal to minus y minus 1. So, x is equal to minus y minus 1. So, it would be And again, the biggest chance of error here is we got two negative signs over there, we got two negative signs here. We got to be really careful with our negative signs. So let's just do it with no chance of mistake. I'm going to put a negative. Everything I see here, I'm going to write in place of y. Minus 9 minus root 105 over 4. And then I'm going to subtract 1 from that. Now let's remove the parentheses. What do I get for x?
9 root 105 over 4.
Plus root 105 all over 4 minus 1. Can I simplify that?
No.
Well, up here, actually we could. We can split this into two fractions. In other words, x is going to be 9/4 plus root 105 over 4 minus 1, which is useful because now I can combine the minus 1 with the plus 9/4 and I get 5/4 plus root 105 over 4. So that is the x value that goes with this y answer. So there's one solution. Now remember, what we're looking at here is an ellipse transversed by a straight line. So I need another solution. Remember, x is equal to minus y minus 1. Well, for my other solution, I'm going to plug that in for y. Again, parentheses are extremely important here. Remove the parentheses. What do we get?
Minus root
9 what?
9 minus root 105 all over 4 minus 1.
And we can do that same process. In other words, I can get rid of that minus 1 by changing that to 5 instead of 9. So 5 minus root 105 over 4 goes with this y solution, and 5 plus root 105 all over 4 goes with this y solution. Makes sense because if you go back and look at our picture, no matter where that ellipse is, I can put it pretty much anywhere, and that straight line is going to cross it at 2 points. There's one point which has an x and a y coordinate, and there's the other point which also has an x and a y coordinate. Okay, what else?
X squared plus y squared equals 13, and x squared minus y equals 7.
What's that the equation of?
So you need substitution.
I know. We'll get to that, but what's that at the equation of? X squared plus y squared equals 13. That is the equation of a circle at the origin with a radius of square root of 13. In other words, x squared plus y squared equals r squared is the standard equation of a circle at the origin. What is this an equation of?
A quadratic?
Yeah, it's a parabola. In other words, if I solve this, I get y equals x squared minus 7, which is a normal-looking parabola shifted down by 7 units, so it's going to go through minus 7. And it looks like it could look like this. We might have 4 solutions. Or none. Because it's also possible that it might miss that circle altogether. If the parabola looks something like this, I don't have any solutions. So let's see. We're going to solve it by substitution, which means we're going to solve the second one, which I've done already. Now we substitute that in for the first one. So we get x squared plus x squared minus 7 quantity squared minus 7 equals 13. Now, wow. Well, let's square it, expand it, and see what we're looking at.
That's 4.
Remember, the middle term is going to be 2 times that times that. When you memorize a binomial expansion, that's what you memorize. So it's 14x squared. And I didn't FOIL that, I just based it on memory. Okay, now let's put this into, simplify it. What's next?
Wait, where did that x?
It's all I'm doing is ordering the polynomial, so I have the highest degree on the left. Next is going to come x squared. How many of those do I have?
Negative 13x squared.
And my numbers, all 3 numbers, convert to what?
5.
Uh-huh.
Wait, yeah.
Now, how do I solve that? Oh my goodness, you got to be kidding me. It's so close to a perfect quadratic. Are there any factors of 35 other than 7 and 5?
No.
It'd be so much better if it was 8 and 5. Could I have gotten the wrong number here? 49 minus 7 is 42, minus 13 is 35.
Wait, 42. Let it be 39.
What's that?
Let it be 39.
Well, I just squared 7. So 7 squared is 49. And then I have this minus 7 here.
42 minus 13, wouldn't that be 39?
Yeah, there you go. That's going to help, I think. No, it doesn't help.
29.
29. Gosh. My hearing's going as well as my mind. Still doesn't help. Because there's no factors of 29 that add to 13. So, how do I solve this for x?
I'm not sure.
It is a quadratic in disguise. In other words, it's a quartic, but I can turn it into a quadratic. And one way to look at this, in other words, if this was factorable nicely, then I would just have x squared minus something times x squared minus something else. But since we don't have any factors of 29, I can't factor it normally. I'm going to have to use the quadratic. Well, it's not real easy to see that this is a quadratic. Let me use something called U substitution. Are you familiar with this?
No.
If I let u equal x squared, then this turns into u squared minus 13u plus 29 equals 0. So it really is a quadratic, and I can now apply the quadratic formula to solve for u. So what is u going to be? We'll get to x, but first we got to solve for u.
Is anything multiplied?
We're going to have to use the quadratic formula because we can't factor that. So what's minus b?
13 plus or minus negative 13 squared.
Don't forget that square root. Both times you've told it to me, you forgot to say square root. In other words, that's the other part of the formula, is it's the vertex plus or minus the square root of the discriminant. So 13 squared is 169 minus 4 times 29 all over 2. Let's see, 4 times 29 is 116, right? 169 minus 116 is 53. So we're looking at the square root of 53, which does not reduce. So, what is x equal to? Wow, I can't believe how hard this problem is. But that's okay. We're going to find our 4 solutions. If u is equal to x squared, x is equal to plus or minus the square root of u, correct?
Mm-hmm.
Just solving this equation over here?
Well, so do we have to square root the entire thing?
Yes. So x is equal to the plus square root of one of those and x is also equal to the minus square root of that, of one of them. And then we had 2 solutions for u, so there must be 2 more solutions for x. In other words, the third solution for x is plus the square root of 13 minus root 53 all over 2. And finally, the fourth solution is minus square root of 13 minus square root of 53 all over 2. And I believe each one of those is different. Yeah, all 4 of those solutions produce a unique number. Now, let's go back to the picture that we had. We know that we're looking at a circle and a parabola. And clearly we have 4 values of x, so this parabola must intersect it in 2 spots, going down and up. Here's our 4 values for x. There's 1, there's another one, there's a third, there's a fourth. each one of those is going to produce a value of y also. How do we get y? We go back up to this equation here. Y is equal to x squared minus 7. So let's erase some of this stuff. Y is equal to x squared minus 7. So what's the y that goes with this?
Um, 13 plus square root of 53 over 2 minus 7.
Okay, what's the y with the second one? Negative. Hold it, if we square that whole thing, we get the same thing, don't we?
Yeah.
And if we go back and look at our picture, we would expect two of the y-coordinates to be equal. Remember that we're looking at a picture like this, and everything is symmetrical. So this y-coordinate should be equal to that y-coordinate. And that's what we're finding. Those two y-coordinates for the two different x-coordinates are the same, and these two y-coordinates are going to be the same. And this one is, when I square that, I get 13 minus root 53 over 2, and minus a 7, minus a 7. And this one, I don't even have to do the math. I know it's the same thing. Just because I know it is symmetrical, and we're going to have two y-coordinates that are the same. So we've got 4 solutions. There's 1, there's 2, there's 3, there's 4, which matches our picture perfectly. If we did not get 4 unique points on the xy coordinate plane, then we probably did something wrong. It's very possible that we would have gotten no solutions. And it's even possible that we could get precisely 2 if that parabola were such that it was tangent to that circle at one point right there, then we might only get 2 points. But it either is tangent or has no points or has 4 points. We solved it. We actually found all 4 points. So we know that the picture is like this. All right. That's one of the hardest problems I've done in a long time in terms of just the amount of work there was to do it. That's based on the school you're going to. They go above and beyond the Common Core.
Oh, yeah. Find the center and the radius of the circle.
Okay.
X minus 2 squared plus y plus 4 squared equals 9, and sketch its graph.
When I said the equation of the circle was x squared plus y squared equals r squared, that's for a circle at the origin. The more robust equation of a circle anywhere is x minus h squared plus y minus k squared equals r squared. This is the equation of a circle anywhere, where the center of the circle is h and k. So, given our equation, where's the center of that circle?
2, negative 4.
And what's the radius of the circle?
3.
There it is. So everything starts with the general equation of these conic sections. And you're definitely going to want to memorize the general equation of parabolas, circles, ellipses, and hyperbolas before you're done. You're going to have to know all of them. They all have x minus h and y minus k. None of them are plus. Won't be until you actually get to calculus where you see an x plus h again. Pretty much everything in pre-calc and algebra 2 is always x minus h. So if you ever wonder whether it's minus or plus, just assume minus. What else?
Circle A has the equation x squared plus y squared minus 6y equals 7. Line B cuts through circle A such that the segment of B contained within A is the diameter of circle A. Line B also goes through the point 3, 0. What is the equation of line B?
Okay. Well, let's see. We should be able to do this. What can we do with circle A? How would we graph that? In other words, how do I put circle A into the general format?
Would you do x squared plus y squared minus 6y minus 7?
Well, no, but you're close. In other words, if I put parentheses around the y terms, I can complete the square, and then I can put it into x squared plus y minus k quantity squared equals some number, and I'll know the radius of the circle.
So would it be x squared plus y squared minus 6y plus 9 equals 7 plus 9?
Yes. So now the equation of that circle is x squared plus the quantity y minus 3 squared. That's why we completed the square, was so we could write it like this. Now we know a lot about that circle. Where is the center and what's the radius?
Center is 0.
0, 3.
And the radius is 4.
Okay, which means it goes through that point. So we're looking at a circle. Boy, I'm a good artist, aren't I? So that's the circle. Now they're telling us that there is a line that goes through the point 3, 0. Well, we know that this is at 3. So it looks like that line, and it has a diameter, or it has a length of 2 times the diameter. So that line must 2 times the radius, right?
Mm-hmm.
So doesn't that circle have to do that? In other words, if it goes through the point 3, 0, and it has a length of twice the radius, or the diameter of the circle, then that's the only way I can draw it. I got to put it through the point 3, 0. I got to put it through the center of the circle in order to make its length be a diameter length.
So it would be 32.
Well,
Wait, no, it would be
I've drawn the picture. Now we have to figure out the equation of that line. Well, we can see that that line goes through this point, and it goes through the center of the circle. We know that point. So what's the equation of a line that goes through this point and this point? What's the slope?
Well, the slope?
In other words, the first thing to do to figure out the equation of the line is to calculate its slope.
It would be y m equals negative 3, no, yeah, negative 1 over 3?
It's negative 3 over 3.
Oh, negative 3 over 3.
So negative 1.
Negative 1. And then,
Now there's a couple of ways. Once we have the slope and one point, we could use point slope format, or we could use y equal mx plus b and solve for b. Most people are actually a little more comfortable with doing it this way, even though it may be a step longer. So all I'm doing is plugging in the slope of minus 1. And now I'm going to pick a point and plug it in for x and y, and I'll be able to solve for b. I can pick either point. Let's pick that point there. So 0 equals minus 3, because I'm plugging in 3 for x, plus b. Solving for b, b equals 3. Now we know the equation of that line. Minus x plus 3. Which fits our picture perfectly. That line looks like it has a slope of minus 1, and it goes through the y-intercept at 3. Seems to satisfy everything. When you are working with conics, there's a lot of completing the square. And the reason, of course, is that everything in conics is x minus h squared plus or minus y minus k squared. So the way you produce these is by completing the square with any information you have. In other words, we knew that it was y squared minus 6y, so if I can complete the square, I can write that as a y minus 3 squared. And that's my goal every time I run into a polynomial that looks like, in other words, when we looked at this polynomial, we could tell that that's a circle. It has to be a circle, because I know it's going to turn into an x squared plus y minus something squared equals r squared. That's the equation of a circle. If this was a minus sign right there, then it's the equation of a hyperbola. Probably have time for one more, as long as it's not a super tough one.
X minus y equals negative 1. Y equals x squared plus 1.
X squared plus
1.
plus 1. Let's graphically look at it. Bottom equation is the equation of a parabola shifted up by 1. And this is the equation of a line. That's y equal x plus 1. So that has a slope of 1, goes through that point right there. So what we're looking at is something like that. So we would expect two solutions, both of them having an x and y value. So if we solve this, no, I guess we don't need to solve the first one. We can substitute immediately, can't we? So we got x minus the quantity, x squared plus 1, equals minus 1. And that turns into whoops, what did I do?
Shouldn't it be plus x?
Yeah, I don't know what I did. Yeah, that's exactly what I did. That's what I meant to write. Well, the ones cancel. If I divide both sides by minus 1, I now get x squared minus x equals 0. I don't have to apply the quadratic to that. I can just factor that out. So x equals 0 or x equal 1. Does that fit my picture? What did I have? I had a straight line and a parabola. And I know the line goes through that, has a slope of 1, so I would expect it to go through some point up there. Clearly, that's x equals 0, and that's x equal 1. And the y value here is clearly y equal 1 when x equals 0. And when x equals 1, y is equal to 2. So this point is 1, 2. And this point is 0, 1. And we have two solutions only. All right, let's wrap it up there. You have any last questions that you could ask that I could answer quickly? Unfortunately, I have an 8 o'clock that I got to get to also.
Yes, I'm good.
You're good? Okay. I will talk to you next week.
All right.
All right. Bye-bye.